If you're on this video, it probably means you're interested in Astra. And for those who don't know, Astra is an observatory control software written in Python, which means it can run natively on Windows, macOS, and Linux. And once set up, you can even check out what's happening at your observatory on your phone. Astra was designed and intended for autonomous robotic observatories, and it was designed here at ETH Zurich, where we're currently on top of the tallest building with the student half-meter telescope. However, it's also operating in various other observatories, including one in Chile, in Paranal, the Speculus Observatory, and also in Mexico. In this video, I'm going to be showing you a clean installation of Astra, setup, and the first calibration observations you should be making. And for this, we need to get onto the computer. To begin, please ensure you have Git and UV installed. If not, please check out the description. First, we're going to get the repository through the git clone command. We're then going to navigate into the folder. Next, we'll install the necessary dependencies, and here I'm using UV sync. Once the environment is ready, you can run the UV run Astra command. It's important to note this initial run doesn't start the observatory. It instead launches a configuration wizard in your terminal. And here you're going to be asked to set your assets path. So this is where your logs, your images will be saved. I'm going to choose a default in my documents. You'll be also asked if you want to download a local Gaia 2MAS catalog. You can say yes, and I'm going to download it from Zenodo. And for testing, I'm going to choose a low magnitude cut. And then lastly, it asks for the name of your observatory. And here I'm going to name it after my university, ETH. After the wizard has finished, Astra will automatically exit. And this is a deliberate part of the setup process. Astra has now generated several template configuration files that you'll find here. So let's open that up. I like to use VS Code, but you can use any text editor of your choice. And here you'll find the observatory configuration file and the FITS header configuration file. And there's configurations for all common ASCOM Alpaca devices, where each will have information about like what you call it, which is a unique identifier, its IP address that you'll find under your network, and the device number. And in principle, you can have many telescopes and many focusers. You would just have to change the respective names and addresses for this. Each device has some unique configuration that you should be mindful of. So with the telescope, for example, you have the pointing threshold for plate solving and pointing correction. By default, I've put 0.1 arc minutes, but if you need a finer tolerance, you can change this. Whether your telescope needs a meridian flip, and how many minutes past the meridian to flip. And there's also guider-specific parameters, and your main camera performs as the guider, but in principle you can use a secondary camera for guiding, and these parameters will be paired with that camera. And then you have your focuser, and here you define your focus position, and autofocusing will change this number when you run it. Then most importantly, you have your camera. And here you set your usual parameters such as temperature and the tolerance for it to reach, cooling timeout, flats, where Astra does sky flats. And here you can set your target ADU and the tolerance around it, and the bias offset that your camera has, which it uses to calculate the exposure time for the next image, and your exposure limits for your flats, should you want to confine that. And the most important part of the camera configuration and to Astra is this paired devices. Astra uses the camera as the main navigator to connect to all your respective devices. Because the camera will have, once it saves its FITS images, it needs to know which devices to communicate with to save all the respective metadata. So for example, this is the normal setup, and as you would expect, you'll pretty much want all your devices, but for some reason you don't want to have a filter wheel of a second camera part of the metadata of your first camera, then you can choose this here. Then you have your dome, and this has a very important parameter where if you have a rolling roof where your telescope requires to be in a specific position, Astra will close the observatory
parking the telescope first and then the dome. But should there be an error, some observatories can close with independent of the position of the telescope. And here we want to make sure that it doesn't, should there be any issues with the telescope. But for most observatories, you'll probably set this as true. And if you have multiple telescopes for some reason operating under one Astra, you can specify the dome it's under. Then you have the filter wheel, observing conditions. So this is your weather station. One nice thing is that Astra has like an internal safety monitor, which monitors the respective weather station parameters and sets what limit to trigger the closure of the observatory and how long the parameter needs to be safe for before reopening again. And you can have different layers of safety. So if it's incredibly humid, the telescope won't open for a long time. And you can add more or remove some. But the important part here is that these parameters must also be in your FITS headers, because the database uses the FITS headers as the starting point. And then lastly, you have your safety monitor. And this also has this parameter of max safe duration. And on top of that, we have miscellaneous. So we have a backup time for all the data that Astra's been collecting in its database, and it saves it into CSV files, into an archive folder. If you have webcams, you can feed the address and display it in the front end. And similarly for all sky images, if you have a latest image, it will also pick that up. And file templating as well is optional. So if you don't like the way that I have named things, you can change the templating. So here, I'm just going to follow the convention I've set here, and I'm going to rename the observatory name here to be the name of my observatory. So now I've changed all of them. But I also would like to add one more parameter to my closing limit. So I want to have sky brightness. And this is following ASCOM commands. So you'll find this as an ASCOM command if you look at the ASCOM documentation. And we don't want to open when the sun is up. And the weather station I have at around 2000 lux is when this number is appropriate for us. And max safe duration, I'm going to say 15 minutes. Save this. But now I've added this here. I should also go to my FITS header configuration and add that, which is under my observing conditions. So I'm just going to copy sky temperature and change this brightness. Okay, to go into this more deeply, this is just a CSV file that explains all the headers that will be populated in all the images. And so we have the standard convention of this capitalized header, the data type it is, whether it remains fixed or if it's dynamically populated, what sort of device it's coming from. So here we have some AstroPy defaults, which is the library I use to save the images. Then you have static, which is the number doesn't change. It's something that you have fixed. So for example, the telescope name. I'm going to call it Heidi for fun. And then the last part is the comment that describes or provides more context to the FITS header. And if you don't like a particular row, you can just get rid of it. In terms of the other types, you have Astra, which is something Astra itself will populate. So for example, the name of the object, it will come from the schedule. And so Astra has to populate this in. And then the last type is a direct command to the ASCOM interface. So here you can get the binning of the camera, the position of the filter wheel. And here my dome doesn't have, it's a rolling roof, so it doesn't have an azimuth position, so we're going to get rid of that. Okay, so now we've changed these two. Astra in principle will begin, but it won't be very happy because the Alpaca devices aren't active. Some of our devices are not natively Alpaca, so we have to use a translation. And here I use ASCOM Remote. And ASCOM Remote permits me to use a standard ASCOM driver and expose it to be Alpaca compatible. So here I have my camera, filter wheel, telescope, and focuser set up like this. But everything else in my setup, the observing conditions, the safety monitor, the dome, are all natively Alpaca. Once you're happy with the setup and you've double-checked everything, you can now run Astra again. And here it will connect to all the devices. So once it's successfully run, one of the last things you should see that is running at the local IP address. Okay, we are at the computer a little later. So now it's nighttime, and here's the user interface. So we have all the devices configured and polling data for the database. And I've also added some images from the all-sky camera we have and some live feeds from the security cameras we have outside as well. So this is our summary page. Then we have our log page, which shows the schedule, which I will explain a little later. The log, which shows the startup sequence. The weather, showing all the parameters that my weather station can do. And then a graph, history of the past 3 days. It doesn't look particularly exciting right now because we've only been observing, well, we were on the computer earlier and now at night. And then finally, there's a control page where you can see a nice, pretty picture of the night sky and where the telescope is pointing. And then some minimal controls. Then on top, we have the name of the observatory, the UTC time, whether the watchdog is running, whether the weather is safe, whether the schedule is running, and whether the robotic switch is on. With this, we're going to be following the operation guide on the documentation. And here, I thoroughly recommend you read as much as you can to fully understand how everything works. Most importantly, you should fulfill these requirements. So I highly recommend you have an independent safety monitor in the sense that if this computer fails, you have some system that will automatically close if the weather's bad, that your hardware is all properly configured, as we did earlier with the configuration files, but also the properties of the ASCOM drivers themselves should be properly configured for your setup. And then lastly, timekeeping should be accurate for all devices, that being your computer and the telescope. And we're going to be running the first schedule, which is to open the observatory, run an autofocus, and calibrate the guiding parameters. To learn more about the specific actions, you can click on these links and it will point you towards all the possible methods you can add to each method. So, for example, the autofocus action has many parameters which you can add on top. However, they're not all required. As you can see, we have only specified the exposure time, the filter, and whether we're doing a search relative to the current position of 1,000 steps here. And then we're doing 2 runs, one of 30 different exposures, and then a second run of 20. And then we have calibrate guiding, which also has parameters you can tinker with. So I have taken these and I have now added it to the observing schedule, which is simply under the schedules folder, and it follows the naming of your observatory.jsonl. And here we have the open, the autofocus, and the calibrate guiding. And what's needed to be changed from what you copy over is the name of the camera that directs the whole observation, and the start and end times that each action is going to be running for. I've also changed some minor things. So the exposure time, I've lowered it. I've also changed the filter, and I've also changed the number of steps just to make it a little bit faster for me. And I've also added binning to both imaging schedules for the reason that we have a 100 megapixel camera and I don't want to be dealing with so many heavy images. And I've also changed the number of cycles for the calibration. So normally it's 10, and for here it's 4, just to speed things up. Okay, and we return to the user interface. You can see the schedule is also loaded here, and you can see all the parameters loaded up. Equally, you could edit the schedule here and change things to your will. Either works fine. Programmatically, it makes sense to just change that file or send it through the API that Astra has. And now the weather is safe. I mean, the webcams also show that it's nice and safe up there. So we're going to run the schedule, which means turning on the robotic switch. And now it's going to be opening the observatory. That is the first run. And here you can see the enclosure opening, which is super nice. Okay, we have opened the observatory, and now we're running the autofocus routine. And you can see the latest image on the user interface, and equally you can see it saved in the images folder. So here we have a nice, quite well-focused image actually, but we'll run through different positions, and now you can see an out of focus one, a nice donut, and we'll do 20 of these images. You can also view the images from the front end. So here, for example, we have an inbuilt viewer. It downloads a low resolution of the image, and then you can increase the resolution. In this case, it's a 25 megapixel image since we've been by 4. It takes a little bit of time. But once we're there, you can navigate the image and see the pixel values. And then also, if you are so interested, you can see the FITS headers as well and change the scaling to reveal more information or less. Okay, we're done. I had to run it twice because the first time it didn't produce such a beautiful V-curve, even though the focus position was very good. And you can see here, this is the first focus curve. And arguably found a good position, but the second time I ran it much wider and it did well. Okay, next is to run the calibrate guiding. And this points the telescope to 1 hour east of the meridian, 0 declination, and then shifts the telescope in a rectangle effectively and calculates the pulse guiding angular shifts such that we can apply to the guiding calibration parameters. The calibrate guiding is done, and that was done in about 7 minutes. And we can see now, if we look at the config, that the parameters have changed. Okay, and once you're happy with this, you can turn off the robotic switch and the schedule, and you can see it processes the images, completing the headers, filling up all the metadata. And just to show you data from a telescope using Astra, one of the telescopes in Chile, here you can see a stack of one of our infrared instruments, and you can see the light curve is relatively flat of our target star, and the stability of the guiding was within 1 pixel in both axes. 1 pixel equates to about 0.3 arc seconds. And to note that this infrared instrument has a bunch of bad pixels and hot pixels, which didn't confuse the guiding. Here you can see the telescope gathering data that night, including doing calibration flats in the morning.
Astra comes with a bunch of features that one should expect to find at an autonomous robotic observatory, such as observatory actions under continuous weather supervision, object observations with plates solved, pointing correction using offline Gaia 2-mass catalogs, PID-controlled auto-guiding, sky flats, and autofocusing using automatic star selection. I'm sure many more features in the future, since this is an open source project, and I really encourage contributions from those who are interested. I hope this video was interesting and useful, and if you have any issues, please post them on the GitHub Issues tab, or feel free to email me directly. Thank you for watching.